Section 24.4. Components of the atmosphere. So it may not seem like it, but Earth's gravity is strong enough to hold the air particles close to the surface of the Earth. So the density of the atmosphere actually decreases as altitude increases. So as you go up, there's less and less and less air. And all of these air molecules form the Earth's atmosphere. The three most abundant molecules in the Earth's atmosphere are nitrogen, oxygen, and argon. Nitrogen is the most abundant, even though it's not what we use to breathe. We do need some of it present to exist. If you breathe pure oxygen for too long, you can become affected by the lack of nitrogen. Oxygen is, of course, what we use to live, and argon, which is about 1% of what's in the atmosphere, is left over from things like atomic bomb tests that generate a lot of noble gases, including a lot of argon, as a byproduct of the radiation. The weight of all the air molecules on the surface exerts pressure onto the surface, known as atmospheric pressure, and this pressure keeps the oceans from boiling away into space. So here you can see all of the gases in the atmosphere, not just the main three, and the gases include other noble gases like neon and helium, but also water vapor, carbon dioxide, ozone, carbon monoxide, and then sulfur dioxide and nitrogen dioxide. One important level to point out is the level of carbon dioxide in the atmosphere, which is increasing steadily over time, particularly due to human causes. So if we look at the vertical structure of the atmosphere, 50% of it is below 5.6 kilometers. So most of the atmosphere is within 6 kilometers of the surface. 99% of it is below 30 kilometers. And then as you go out towards space, the atmosphere steadily thins out. And we divide the atmosphere into different layers based on distinct characteristics. The lowest layer is what's known as the troposphere, and it contains 90% of the atmosphere's mass. It extends up to about 8 kilometers at the polar regions, and about 16 kilometers above the equator. The troposphere is where all of Earth's weather occurs. Jets will fly near the top of the troposphere in order to reduce issues due to weather while they're flying. And in the troposphere, the temperature decreases with altitude. So as you go up, the temperature goes down to an average of negative 50 degrees Celsius at the top of the troposphere, about 14 to 16 kilometers off the surface. Above the troposphere is the stratosphere, and the stratosphere extends to about 50 kilometers above the surface. Here's where ozone is formed, and this is where the ozone layer is, and UV radiation from the sun is absorbed by the ozone layer. The heat generated by the absorption of that radiation causes the temperature to go up, and so you find that it's about 0 degrees at the top of the stratosphere. Above the stratosphere is the mesosphere, and it extends to about 80 kilometers above the surface. Here you have little radiation absorbed, and the temperature drops down again to about negative 90 degrees Celsius. Above the mesosphere is a region called the thermosphere. The thermosphere is, by height, the largest component of the atmosphere. Here the temperature increases up to 500 degrees Celsius, but this is misleading in terms of the way we understand temperature. In this region of space, there's not a lot of air molecules there, so the molecules that are there have a lot of space to move around, and they can move around very quickly. Because temperature is measured as the average kinetic energy of these particles, then the temperature can be really high even for a very small amount of particles. So even though the temperature in the thermosphere is very high, if you were to be exposed to it, you would still freeze to death. In the upper regions of the atmosphere is a region known as the ionosphere. It's not pictured here because it extends through multiple layers of the atmosphere. And here's where solar radiation from the sun will interact with particles in the atmosphere and generate ions, and these ions can generate auroras. The ionosphere is also the reason why on a night where there's no moon, there's still a faint glow from the atmosphere. That faint glow allows things to not be totally black. Above the thermosphere is what's known as the exosphere, and this is the region that is essentially the entrance into interplanetary space. It starts at about 500 kilometers above the surface. Here, as you would expect, the air particle density is really, really low, and there's just not a lot of stuff going on. This is right as you enter into what we would call space.